Well, welcome back to PMBOK Deep Dive into their 5th edition. This is Planning Quality Management activity under the Project Quality Management Knowledge Area, which happens to be, by the way, Chapter 8 in your PMBOK. So the first activity or process we're going to look at is 8.1, where we plan for quality management. And I just want to mention again that just like risk, quality management is one of those activities or knowledge areas that project managers tend to overlook for any number of reasons. They don't understand it, they don't think it has value, or they just think, well, I'll just do it myself. What's quality management? Well, that's a big mistake, especially on a larger project, because remember, project success means that, among other things, your customer is satisfied. So if you produce something that is not within quality and you have no way of assessing the compliance with any kind of quality metric, you're going to be in trouble because they won't be happy. So you need to have a quality plan in place of some sort so that you can consistently and repeatably measure the quality of the products that you're producing, your deliverables, as well as the quality of your own project processes. So project quality management has a couple of definitions we'll look at. One is it's the processes and activities. PMBOK is all about processes and activities of the performing organization, which would be you, to determine that, project quality management, to determine that quality policies are in place, quality objectives have been defined, and someone is responsible for quality on your project. If it's not you as the project manager, it needs to be someone on your staff who is responsible, maybe not full-time, but responsible to monitor and watch over quality on your behalf and for the benefit of the project. And why do that? Because you want the project to be able to satisfy the needs of the purpose for which it was undertaken, which is to produce a good quality deliverable for your client. Quality management is also all about identifying quality requirements and standards that you need on your project and that you need to apply to your deliverables as well, and all the documentation that may be involved so that you can demonstrate empirically that these deliverables and your project are in compliance with certain quality metrics or requirements. So that's what this is all about here. There are 3 processes in 8.1 where we're going to produce our quality management plan, planning the management, and then we're going to look at quality assurance as a process, 8.2, and 8.3 is quality control. And I'll tell you up front, so that you're not astounded perhaps when we get to this later here, is that the sequence that PMBOK has presented these in the guide are in this order: plan your management, perform quality assurance, and do quality control. In reality, well, they did this for a reason, because planning is a planning process group. Perform quality assurance, as we'll see, is an executing process group, and quality control is a monitoring controlling process group, and those are the natural order of the process groups that they're always presented in. However, in this instance, and this is the only one within PMBOK, in reality, in the real world, you would plan your quality management and then you would do quality control. And what you do within there, because it's monitoring and controlling, you create your metrics that you will then apply to the deliverables, and you will then compare them in executing under quality assurance. So they're actually done in that order. So don't be thrown with that later when we say this again. But that's another thing that took me a minute to understand, or actually more than a minute years ago. Geez, how can you do this without that? Why is that in that order? Well, it doesn't make any difference what order it's in. You do quality first, where you create your metrics, and then you do your quality assurance, where you actually compare the metrics against deliverables. So plan quality management, and by now you should know just by rote, it's a planning thing. Where does it belong? It belongs in the planning process group. And like I just mentioned, if you're astute, you'll know quality assurance is an executing process, and quality control, obviously, because it has control in it, is a monitoring and controlling process. So we're going to look at all of these But right in this module, we're going to look at planning for quality management. Oh, and by the way, executing, I want you to just show you this just to let you know that in the executing process group of the 47 processes in PMBOK, there are only what? 1, 2, 3, 4, 5, 6, 7, 8 of those processes. Okay, about 5% of them are executing processes. So, doing the actual things, making things happen, and working are only these here. You do that, and 4.3 is the major one where you actually execute the deliverable. You're executing your project management plan. You're building stuff that's in your scope, your scope baseline, your work breakdown structure. You're doing all those detailed tasks to build your deliverables. That's the main one. Then we take that deliverable. If you remember from the beginning, once you have your deliverable, it goes out to 8.3, which is quality. And then you acquire your project team, your human resources. You execute those actually by developing them and managing them. Manage communication, that's executing. You conduct procurements, you're executing your procurements. And then you manage your stakeholder engagement actively as an executing process. So 8 of them. Quality management definitions. Quality measures, techniques, deliverables specific to deliverables. Each deliverable may have a different set of metrics that you need to compare to depending on the deliverable. Quality, the grade of it, the precision, accuracy, those things are all components of quality that you may need to apply to a deliverable or even a subcomponent of the deliverable, so that when the whole deliverable is done, that whole thing has this encompassed quality to it. ISO, the International Standards Organization, they're international quality management standards. Okay, what they say, just like PMBOK does, is customer satisfaction is fundamental to good quality. You give quality, you'll get customer satisfaction. Prevention over inspection is a big one. And this should certainly make sense. You'd rather prevent a problem by applying quality to it in the interim before it gets to the point where you deliver it and you say, look at it, and now it's inspected and you say it doesn't meet quality requirements. And then there's rework and cost of quality. You don't want that to happen. You want to prevent it before you have to inspect it out. Continuous improvements are always a quality feature, either in the deliverables you make or in your project processes. And even these PMBOK processes have quality components to them to make sure you do a quality job with all of these 47 processes. Management responsibility, again, you need to be responsible for quality, or someone on your staff needs to be responsible for quality to you. Okay, you might even hire a third-party contractor to be responsible and do your inspections and so on. But whatever it is, quality, you're responsible as project manager. And then they have the concept of cost of quality, COQ. If you see that in a PMP exam, COQ, cost of quality. That's what it costs to maintain quality, and it's also what it costs to recover from quality defects. It could be positive, could be negative. And it's in your budget. Quality, you need to be funded to do quality activities. And unfortunately, you'll find that if it's not at least risk, if management needs to grab funds from you and your project, and this happens, you might know often, they come and say, well, we're reducing your budget, you don't need quality. They'll pick on quality more than probably anything else. You don't need quality. We have a quality staff over here, they'll look at it, but they're not on your team, they're not dedicated to you, their motivation really isn't there. You need to have it on your team. Quality in your project, embedded in your budget. So 8.1, quality management. The inputs here, basically inputs, are requirements come in, because that's your work product requirements. You need to apply quality metrics to them eventually, so how are we going to plan for that? Your risk factors come in because they affect quality, so how are you going to plan to address risk while you're addressing quality? You do assessment methods on how we're going to assess quality, and you put that in your plan so that when you create your metrics, you're looking at how you're going to assess. And the outputs are your actual quality management plan, which includes 2 basic components. Your assessment criteria is how you're going to create your criteria, and a process improvement plan. Mr. Deming, you heard of him, a Plan, Do, Check, Act quality manager from Japan way back. That's why the cars all of a sudden got be produced really good cars, when prior to that you say, oh, Japan, junk. Well, he turned that all around, and he did it with process improvement. And so we're going to look at that here also. We're going to come back in a minute and look in detail at the data flow diagram for plan quality management. Okay, here's our data flow diagram for planning quality management. Again, project management plan comes in with all the subsidiary plans, including the risk management plan. Your stakeholder register comes in because your stakeholders have a great influence over quality and their concerns and considerations for that. Your requirements document, again, which is a level above or less refined than your actual scope baseline, but these are your overall requirements, and they give you a certain clue as to quality requirements. Your risk register certainly comes in because it affects quality should risks occur. And the enterprise, again, gives you assets and other things that you can use relative to creating your plan. The outputs, the main outputs are, well, your process improvement plan that go into 8.2, where you're going to actually perform executing quality assurance tasks, and we'll see what those are in the next module. Of course, the your quality management plan is the main output from this process, and it goes into control quality, so you can do that. And your quality metrics, as I believe I mentioned earlier here, are an output of plan quality management actually in the plan, or during plan quality management, in the quality management plan itself, you will have determined what those metrics are, and they're part of the plan. And they go into quality control, and we'll see that that's where your deliverables go. You apply those metrics to them, and deviations from those metrics go in to perform quality assurance so that they can do some activities there to bring things back under control and things. You'll see what that's all about when we get there. And now here we have quality checklists come out of your plan too. You're going to create quality checklists, and you're going to put them into control quality, so they have these checklists so they're consistent in what they do and when they apply the metrics to your deliverables. And again, here's checklists. So, and then identify risks and other project documents. So we'll see those as we go through here. So your PM plan, it's your scope baseline primarily that comes in. These are your products you're delivering down to the detailed items. Your scope management, scope statement in particular is in there too. Your scope baseline, cost baseline, other subsidiary plans all come in for reference as you try to plan for quality. Your stakeholder registers, you may have very quality-minded stakeholders. You want to keep them engaged regardless of quality or anything. You, of course, want to keep them engaged with your project. The stakeholder register, here's where you have your threats and opportunities, which could affect quality severely or in a very beneficial way, depending on what they are. Your requirements documentation, your stakeholder documented quality requirements would be in there up at that level too. And organizational factors, process assets such as working conditions, standards, regulations could affect quality, especially working conditions. If you're in a dirty environment, maybe if you're building some intricate equipment, think of Intel or Apple when they build their intricate electronics. They're in a dust-free environment. So that's a working condition over which they try to control, but they don't have ultimate control over, but they learn how to control it. Okay, that's EEFs. And then they have their quality policies and procedures and lessons learned. And for, again, Intel, Apple, and those kind of environments, they certainly have quality policies and procedures. And and when they have lessons learned, boy, they use those to their advantage to improve their products. So, cost of quality again, COQ. Let's look at that. And you're going to have to know these differences in these terms for the PMP exam, because they'll certainly quiz you on this in some manner. You have your cost of conformance, and you have a cost of non-conformance with your quality standards and metrics. You have, under cost of conforming to them, you have your prevention cost, where you really want to spend most of your money, is to prevent problems with quality. So you want to build a quality product. That involves training, good documentation of the processes as you build things, right? It could be equipment that helps you, like robotics, on a larger scale, robotics versus manually putting stuff together. And that's one of the reasons, the quality of automobiles has gone up tremendously, because they have robotics. Very precise, very quick, very accurate, very repeatable, versus somebody with a helmet and a welding gun, much better. And, you need to have the time to do it right in your budget. That's why you don't want to outsource this to a third party, and even in your company for quality, because they're not going to give you the time of day necessarily. So you want something under your control in your project, in your budget. And there are the appraisal costs of conformity, that is inspection and stuff like that, testing, destructive testing if you need to do that. Of course, mostly it's testing and primarily inspections against metrics. So this is money spent during the project to avoid failures. That's cost of conforming, part of cost of quality. The other side of the fence is the cost of non-conformance. Internal failure costs, failures found by you within your own project, is bad enough, okay, and that is like rework. You may need to scrap something and just start over, waste all that time, money, effort. Your stakeholder wonder, what are you doing? Why did it happen? But that's internal. Now, the worst thing that can happen is external failure costs, failures found by the customer after you turn over an allegedly correct product. You don't want them to figure that out, because if it's in production, for example, and it breaks because of some faulty piece or assembly or something where it could have been not a problem if you had followed quality procedures, or if you have had quality procedures, you might be liable for that problem way beyond what it would cost to rebuild it. Warranty work, of course, is a natural response to failures after you deliver things. And lost business too. So we're never working with your company again because you don't pay attention to quality, because I found all these problems. No way, you're gone. So the cost of non-conformance is money spent during and after the project. During, because you find defects, and after, because your customer found defects because of failures in the product, defects. So that's cost of non-conformance. Now if you look down here, and again, this is in your PMBOK too, when you build your deliverables and you deploy them out, you deliver them to the client, and finally they're retired, the conformance costs are only within your own organization, within your own project. These costs to prevent and to appraise and assess before you turn something over. Non-conformance costs, because they are internal failures as well as external, they span both build and deployment. So you need to know these features, these definitions, and their impacts. Cost of quality. A cost-benefit analysis is another tool and technique. It's the cost of quality versus the expected benefit. You need to balance these somehow so you're not spending exorbitant costs with trying to meet very tight quality metrics, or maybe it's not really needed. You can back off a bit. So what's the benefit of doing that? At some point, your benefit's not going to go up much as you spend more and more on quality. You got to find that sweet spot with it. Now there are 7 basic quality tools, right over here in the tools and techniques. They're defined as 7 basic quality tools, and these are what's available to you if you need them, depending on the nature of your project and what's at hand, to help you do prepare your quality management plan, and later on you use them as you assess, because we'll see these again later on in a further process here. We mentioned cause and effect diagrams before, fishbone, Ishikawa, and now we're going to actually see what one looks like, not in great detail. We don't have the time for that, but you need to understand what they look like and what their purpose is. Flow charts. Now we're going to look at, there's all sorts of flow charts you can use. One in particular that for some reason the PMBOK gives you this diagram of specifically, so it must be important to them. So you need to know what this is. SIPOC, okay, supplier input, process output customer, SIPOC. Memorize it. Because they were specific in citing this particular diagram the way they did, I'm sure they're going to ask you if you understand what this is and what it's for. So, you know, you list all your suppliers, inputs, process, outputs, customers. Here's your diagram. Requirements, measurements, both for the supplier side and the customer side. And you want to make sure that, you know, you have processes in place for inputs and outputs that satisfy both the suppliers and the customers. So read up about this in your PMBOK and just make sure you understand what it is. You don't really know how this operates actually, but you need to know that this exists, what SIPOC stands for, and that is a quality management type of flowchart for helping you develop quality. And if you do that, you should be good for any kind of question they throw at you. So here are check sheets. These are tally sheets, not checklists. We saw checklists elsewhere. These are check sheets, which is a project. Checklist is a project document. Check sheets are a tool and technique. Okay, and by check sheets when you're doing your quality management are here's something comes in to be inspected, and you will have a check sheet for each one of these deliverables depending on what it is. You may have different kinds of check sheets with content you check off. Is it this, 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 and that's all project documents. Goes in there. So check sheets, Pareto diagrams, and all the rest are here. Here's your 7 basic tools. Here's a fishbone diagram. See, here's the head of the fish, here's the bone sticking out. What you do here is hard to see, but you need to look in your manual, but you have like materials, people, customers, whatever it is. You categorize those, and then in the bones, you put things that relate to them, and you can figure out here, where do I need to apply quality to what, because you don't need to apply quality to necessarily everything to the same degree, remember, so you're going to look at those. Ishikawa, fishbone, cause and effect. Here's flow charts, many kind of flow charts. Maybe you need to look at a flow chart process as you build something. There's quality in that. Are you missing any steps? You need to observe and check and do that. And here's where your SIPOC is one of those, and it was specifically called out. Must be important to them. Check sheets again. Here's your attributes you're checking. Here's your data, or whatever it is that you're inspecting. You can check it, and then it'll be checked against metrics. Pareto diagrams, histograms, control charts. It should be on this line. All of your samples are up and down, but if something pops up here or down here below the upper and lower bounds, then you're out of control. And the key is if you're out of control more than 6 or 7 times, then you got a problem, so you need to address it. And of course, regression scatter diagrams, you take your measurements and they should be all within clustered here. If they're like outliers like this, what happened there? What happened here? Is it going to continue or not? So count them, 1, 2, 3, 4, 5, 6, 7. These are your 7 categories of basic quality tools. You need to know just by name what they are. Okay, we're going to come back then and continue in a few minutes with our look at tools and techniques for quality plan development. Okay, marking. In just a moment, I want to go back just to this last slide for a second and just explain something I might have glossed over a little too fast. Again, although we don't need to go into a lot of detail here, again, you just need to know what these 7 tools are by name. You need to know cause and effect flow charts, check sheets, control charts, histogram, Paretos, and scatters as the 7 tools in case you're quizzed on those. But just for your own, understanding, a Pareto diagram, the purpose of it is when you have quality defects. You could have a defect in a deliverable for this reason or for that reason or for whatever reason. you aggregate all those defects for that item and you put them in this Pareto diagram right here. So if you have, let's say the scale is 1 to 10, you have 5 defects because the thing didn't turn out blue, it turned out green. Okay, so that's plotted here. That's your most defects. And the second kind of defect might be that, well, this label here should have been placed in the lower left, but they put it in the upper right. Okay, and that happened 3 times. So that would be the second instance right here, this bar. And then another type of defect on that item happened twice. That would be here, and then 1 time some other defect happened. And the point with Pareto is you graph them like this, you plot the aggregate total up here so that finally when you're done, you have 100% of all the defects of that item. So here, obviously, if that was the case, you'd look at this and you know what you need to address first. What are these 5? Well, the color was wrong. Well, go see your painter. He's not looking at his requirements to paint it blue instead of green. Or maybe he left and now some substitute came on who's a hot shot, doesn't care. He just saw something. He saw a reject over here that was green, so he painted it green, not knowing it should have been blue. So these help you identify the most worst cases of defects that you can then go after. The histogram is kind of similar. It takes your defects, but it plots it in this kind of diagram here where they aggregate stuff in the middle here, so you can see what your worst tendencies are for defects here, and then they go out into your outliers here. Same kind of effect. But these are all methods of being able to analyze your quality control metrics and results. So now let's talk about benchmarking. Benchmarking, of course, is benchmarking against a known good thing. So that may be all some product or some piece of deliverable or deliverable might be. You have your benchmark here, whatever it is, something comes in, you check it. Yeah, same, okay, benchmarking. Same kind of thing. Design of experiments, you may have to design certain experiments to test certain quality aspects. And again, it's hard to describe right here in this course, but just know that, instead of having a hard sheet to check numbers or something, you may have to actually create an experiment to pump something through to see if it comes out consistently the same way on the other end. Design an experiment. Statistical sampling is where you don't inspect everything, but you inspect a good portion of the population, and that would represent what you would expect from the entire population. And there's additional quality tools, things like brainstorming, again. Here's a good one. Force field analysis is kind of interesting. If you're having trouble with quality on an item, for example, or a process or whatever, force field analyses, again, have many different ways of doing force field analyses. The one I like the most would be something similar to, this down here. You have your issue in the middle, and you have your driving forces on one side, your restraining or opposing forces on the other, and all of these are like that. It just depends how you depict. And this is another example how PMBOK does not recommend or prescribe any particular kind of template or use. They just say, here's how it would work, go do it the way you need to do it. But force field is cool because what you want to try and do is increase the tendency of the driving forces of the positive things, decrease the restraining or opposing forces so that you can finally achieve a better result in the middle. That's force field analysis no matter how you look at it. All right. Nominal group technique is another method of assessing quality, and you should really research that a little bit in case you need it in your project. But the point there is these are other methods you can use. And of course meetings to look at all this stuff as you plan your quality management is the way to go. So eventually you're going to come up with your quality management plan. And it's how your organization quality policies are going to be implemented as you build deliverables and put them through inspection or however you want to do it, and how the management team themselves is going to meet these quality requirements. What are their work activities? What are their processes that will be consistent and repeatable to be able to produce your deliverables consistently all the time? Or even if you do it only once, how they would best work to create that one instance of a deliverable that goes through quality check. A side item here is your process improvement plan. This is an actual project management plan component. If you remember, look at table 4-1, subsidiary plan, and these are steps. It's a plan improving your processes, giving you better quality by improving your processes. And it has, certain boundaries to it, so it's for a particular process, basically. How you configure them and what the metrics are for these things. Future targets, meaning how do you improve it in the future. But basically the whole thing with process improvement is either in when you're building your deliverables or as you're executing your project, which are processes, right? How can you improve them based on lessons learned, and more specifically when you're building your deliverable against metrics, how can you improve the quality so they're always within your quality metrics? That's your process improvement plan. Now here are your actual quality metrics that go into your quality management plan. They're either project or product, which is your deliverables, attributes of those. It's how quality is going to measure it. You're going to have quality against your own processes, or you're going to have quality against, obviously, the deliverables you are building. And it's a measurement. It's an actual value that you're going to compare against whatever it is it's designed to compare against too. You'll have tolerances there. Maybe it's 0 tolerance. It must be this, nothing else. Or it could be plus or minus 3 of whatever the unit of measure is your tolerance represents. So they're in the quality management plan. Here's our plan, here's our metrics, here's what we're planning to do, these metrics right here. Then you go out and you assess your deliverables or your project processes against them, and then you do change requests if needed, and quality improvement and all that stuff. Quality. Things like on-time performance, cost control. Cost control is a project process. On-time performance is a project process. Defect frequency is a building your deliverable process. Okay, and so is failure rate. So all of these methods, you got to have a metric for failure rate, no more than 3 out of 100 if you're doing repetitive stuff like that. Defect frequency, all this. So you actually create the metric in the quality management plan, which is what you use later on under control quality to measure against. And then it goes into quality assurance, where you deal with the deviations and you report them in that manner. And we'll see that actually in our next module when we get to it. Quality checklists. Structured, they're component specific. Remember, checklist, you get your component, yes, 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 no, yes, yes, against metrics that you've created here. That's your checklist, and they're for every deliverable, or perhaps every work process under that work activity that builds into the deliverable at whatever discretion you need it to be on your project. When I say every deliverable and stuff, you may have one checklist that covers 15 deliverables, same checklist, but you may have a different checklist for this kind of deliverable. And it shows the steps that you need to perform to fill out the checklist, and the scope baseline acceptance criteria is in there. That's your basic metric, perhaps. So projects, documents that are updated. Your stakeholder register could be updated because your client now has different attitude toward quality, better or worse. Your responsibility assignment matrix could possibly be updated because of quality. I don't like this guy on my job. He just doesn't do good work. He's not reliable. Change him out. Get somebody else in there that's more reliable, that produces quality work. Could be one fallout of this. And of course, you may have to update your WBS and your WBS dictionary, which are the items you actually need to build down to the work item of, here's how I build this. Takes me 2 hours to do this, 2 hours for this, 2 hours for this, and finally after 6 hours I built this piece. And this piece is part of the deliverable, and it rolls up into that. So that may change because of quality. You may change where it says, here's how you build this 2-hour piece. That may change because you consistently can't do it in that manner. Do it a different way so that, you know, you'll create a better product. So quality improvement, process improvement, that's why those are updates. So we've created the quality management plan on how we're going to manage quality on the project, and we've created the actual metrics that we're going to be measuring against. That's the plan. So next module 18, we're going to talk about the quality assurance and the project quality control, where you actually measure stuff and then you deal with the results of your measurement. So we'll see